Hello students, welcome to Saurav Sir's classes. We are going to continue with the video of limits. Okay, in the previous video I had explained about limits and I showed you how to find the left hand limit, that is the LHL. Okay, that is limit of x or anything x tends to a negative f of x. This is the left hand limit. Okay, then I also taught you the right hand limit, that would be limit of x tends to a positive f of x. So these are the things, a few simple things I had taught you on limits in the previous video. Okay, today we are going to talk about the existence of limits and little more from the topic. So let's start with today's topic. Today's topic is going to be the existence of a limit. Existence, let me just scroll down a little bit. I don't think that's written properly. Let's just rub this off. Existence of limits. Let's understand this. What does it mean by existence of limits? Suppose we have limit x tends to a minus f of x is equal to L. Okay, and then limit x tends to a plus f of x is also equal to L. So you will notice that both of them are equal, right? So limit of x tends to a negative f of x is equal to limit of x tends to a positive f of x. So hence the limit exists. So you see here also it's equal to L, here also it's equal to L, hence the limit exists. So limit exists. Now the left hand limit also exists because it's equal to L, and the right hand limit also exists is because it's equal to L. Individually also it will exist. That means you can write, so limit x tends to just a f of x exists. Understood? Very simple logic. What is the logic saying? Very simple. Let me explain this to you. Existence of limits means if the left hand limit exists, that means it has a value. Okay, if the left hand limit exists and the right hand limit exists, and we know that the left hand limit is equal to the right hand limit, so we can say that limit of the function universally exists. Okay, so we can say that limit of the function exists. Simple logic. All right, so after this existence of limits, we have to learn this part. Although you have learnt it in your higher classes, there is nothing new that you are learning, but what you need to learn from here is the difference between finding a limit. Okay, the difference between the value of a function at a certain point, value of the function at a certain point, and the limit of that function, limit of that function at that point. Okay, so let's understand this with an example. Okay, let's understand this with an example. Let's give you an example. Let's say I give you a function f of x is equal to x square minus 9 divided by x minus 3. Okay, this is the function. I've given you the function. Now what happens if I put x is equal to 3? The function f is undefined, right? As you put a 3 here at the denominator, this function becomes 0 by 0 form. So the function is not defined at x equal to 3. But let's find the limit of the function at 3. So limit x tends to 3 f of x, let's scroll down, limit x tends to 3 f of x is, always happens like this. Just hold on one sec, please don't get rid of the nonsense. So limit x tends to 3 f of x is equal to limit x tends to 3 x square minus 9, put it in bracket, divided by x minus 3. So how are we going to solve this? Limit x tends to 3 x plus 3 x minus 3 divided by x minus 3, so which is equal to 6. So can you see that the limit exists? The limit exists, yes, but the function here, does not exist. At x equal to 3. Okay, so what did you understand from this example? From this example, it is very, very simple to understand that a function may not be a function. Let's go on to the highlighter, because I might need to highlight. Let's use a different color. A function, let's use some other color now, green. Okay, so a function, this is the function. This function, not necessary that the function will exist. Okay, it is not necessary for the function to exist. Okay, it's not necessary for the limit also to exist, but okay, but it can happen that the function is not existing at a certain point, but the limit is existing at that same point. You can easily see from this example that the function is not existing, but the limit is definitely existing at that point. You can also take one example on your own. Okay, so if you are to take an example, you can take this example and write example 2. For example 2, you can take the function, hold on, you can take the function, let's do it with a blue mark pen. So you can take the function, say f of x is equal to x square minus 25 divided by x minus 5, something like this. You can see the function does not exist at x equal to 5. But what about the limit? Let's check that. Very simple. Limit x tends to 5, f of x is equal to limit x tends to 5 x square minus 25 divided by x minus 5 put in bracket, equal to limit x tends to 5, that will be give you x plus 5. Obviously x minus 5 got cancelled, answer is 10. So limit x tends to 5 f of x, the answer is coming as 10, whereas the limit, the function is undefined at x equal to 5. Alright, now sometimes it may happen that the function is existing but the limit is not existing. Okay, sometime, as I told you that sometimes the function is over here, the function is not existing over here, this function is not existing, but you can, if you go down, the limit is existing, but not necessarily every time the limit will exist. There will be some time where the limit will not exist, but the function might exist, the function will exist. Okay, so let's give an example on that. Let's give an example on that. Function whose value at a point exists but the limit does not exist. So I'm going to give you an example. So f of x is equal to box x. What is this? This is the greatest integer function. Okay, this is the greatest integer function. What happens in the greatest integer function? Let's say if I write f of 0.1, you still get a 0. F of 0.2, you still get a 0. F of 0.3, you still get a 0. Okay, like that. If you continue on like that, okay, continue from here, and if you go on to f of 0.9, you still get a 0. Only at f of 1 you will get a 1. So that's called the greatest integer function. I hope you have understood what is the greatest integer function, although you already know what is the greatest integer function. So let's try and show that this function, oh god, just hold on. This greatest integer function, okay, this greatest integer function f of x, what, its limit does not exist but the function does exist. So let's see. Okay, let's go ahead and do this question for you. Okay, so let's start from here only. Let's do with the blue one. Say we know that at x equal to 2, f of 2 is equal to box of 2, that is 2. So the function exists. Function exists. Now look at this. Now let's find the limit of the function. So the left hand limit, yeah, we'll find the left hand limit. What is the left hand limit? Simply at 2 will be limit x tends to 2 negative f of x. Now you need to understand, at when it is limit x tends to 2 negative, that means the graph is approaching from the negative side. The graph is approaching from the negative side. That means you are going to get all the negative values. Negative values means the values that are less than 2. So if the values that are less than 2, the answer limit x tends to 2 of box x, any value that is less than 2 will give you 1, right? Like if you have 1.2, if you have like you had f of 0.9 as 0, so if you have f of 1.8, you're going to have what? 1. Understood? No. So the value is less than 2. Now let's go on to the right hand limit. The right hand limit, the RHL. The right hand limit. So limit x tends to 2 positive f of x, okay, is equal to limit x tends to 2 positive box x is equal to 2. Why 2? Now see, if it is greater, if this part is 2 positive, means the graph is approaching from the positive side. That means we can take values like 2.1, right? 2.2. So if you write f of 2.2 in the box x 2.2, you are going to get 2. So you see the limit over here is 1 and over here is 2. Both these limits are not equal to each other, hence the limit does not exist. So limit x tends to 2 negative f of x is not equal to limit x tends to 2 positive f of x. Did you understand the simple logic? Okay, so what did we learn today? We have learned about the existence of limit, how limits can be, how we can exist, how we can find the existence of limits. Okay, just now only I showed you an example. So existence of limits excuse me you will have to find the left hand limit and right hand limit. I have taught you in the previous video. Okay, this is the right hand limit, and if both of them are equal to L, that means they both exist. That means both of them have to be equal to each other. If both of them has to be equal to each other, then the limit of the function, then the limit x, the universal, the x tends to a f of x exists. Okay, simple logic. Now from here let's go down. Difference between finding the limits at the respective points. Okay, so you can see that in the first example you can see that the function does not exist, right? The function is not existing at x equal to 3. But when you go down, so the function is not existing at x equal to 3, but if you go down and see, the limit of this function does exist at x equal to 3, and the limit is what? 6. So it is existing at x equal to 3. Now if we consider the other example, okay, same thing actually, to show you that the function does not exist at x equal to 5, but the limit of the function does exist. Okay, so what are the important points I'm highlighting? You can see the limit of the function existing over here, right? Very, very simple to see, very, very simple to understand. Okay, let's go down further on. Now in the example 3, we are going to show over here, what have we shown? We have shown that the function exists, but the limit of this function does not exist. So the function is existing, you can see from so many points I've showed you, from here, 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 or here. Okay, so the function is existing at 2. That means the function will exist at all values. Okay, now when you see the RHL, the LHL I mean, what is happening to the greatest integer function? The graph is approaching from the negative side. Here's the graph. Oh, why are you going down? The graph is approaching from the negative side. Here's the graph. So if it is approaching from the negative side, you will have to take all the values that are less than 2. So that is 1.1, 1.2, 1.3. So they will all give you values as 1. Now when the graph is approaching from the right hand side, so you will take all values that are greater than 2, and eventually you will get just 2, like over here I have showed you an example, and the graph is here, okay, approaching from the right hand side. Alright, so now you can see that the limit does not exist, okay, they are not equal to each other, hence the limit does not exist. So that I have not written, that's right. So limit x tends to 2, f of x does not exist. Okay, that's it for today, students. You keep taking as much help as possible, because help is always given at Saurabh Sir's classes. Thank you.